All right. For assignment number 13, the first problem say verify that the infinite series diverges. So we can just use nth term test for, I think, a lot of these, because remember, a series can only has a chance to converge if the terms are approaching zero. Because in the end, the question is, are the terms decreasing to zero fast enough that it's like you're adding zero in the end, for the thing to converge and have a finite sum? So you should just be showing the limit as n approaches infinity of 7 over 6 to the n equals infinity. So this diverges by the nth term test. Now, you could also use the geometric series test. So sometimes there's more than one way to show that a series will converge or diverge. I think I said we're going to learn, I think, like 10 of these tests. So sometimes more than one will apply, and it's okay to use different ones. So the other option is that r equals 7 over 6, which is greater than or equal to 1. So this series diverges, you could also say, by geometric series test. All right, for the next one, I can't use geometric series on this one because it's not geometric. But again, I can use the nth term test because these terms are approaching 1/2. They're not approaching zero. So the limit, you have to show the limit, though, to use this test if this is a free response question. You can't just say diverges by nth term test. So show the limit as n approaches infinity of this expression is 1/2, because this is same degree on top as the bottom. And so therefore the series diverges by the nth term test. Same idea for number 17. Now, I did split this up a little bit just to show, because sometimes you might think, well, wouldn't 2 to the n plus 1 increase faster than just 2 to the n? So let's go ahead and break this up. This is 2 to the n times 2. So when I'm doing my nth term test, this times 2 down here is like having a 1/2. And then you have 2 to the n plus 1 over just 2 to the n. So yeah, this is still essentially a tie. You could do L'Hopital's method if you wanted to get rid of the 1, but this is going to divide out to 1 times 1/2. So that's 1/2 times 1. So again, because that's not 0, the terms are not approaching 0. In the end, it's like you're going to keep adding 1/2. So this series diverges by nth term test. Last one in this section, n factorial over 2 to the n. So again, I can show the nth term test. We know about function races that factorials grow faster than exponentials in the end. Maybe not initially, depending, if I had a huge base number, then the exponential will grow faster for a while than the exponential, but then in the end, the exponential will exceed and grow faster. So this is infinity, and again, diverges by nth term test. And just a quick distinction, remember in 9.1, when we were just talking about sequences, the terms for the ones I'm getting numbers for, the terms converge to 1/2, but the series, the terms add up to infinity. This one, the terms would not converge. The terms would diverge to infinity, and therefore the sum diverges to infinity. All right, for this one, verify that the infinite series converges. So they're giving us a hint here to use partial fractions. So this is where we should be splitting this up. I like to set up the summations and leave a bit of space for the constants that go in front. I'm going to use the cover-up method. So if I want to let n equal 0, I cover up the n, and I plug 0 into 1 over n plus 1. So there's a 1 in front of there. And if I let n equal -1, I have to cover up n plus 1, and I get 1 over -1. There's a minus there. All right, so use partial fractions. The purpose of that is to merge this into one summation here. And then we can either expand out terms and show that the series converges, Or remember, the telescoping series test says that you have a convergent series if this is in its true telescoping form. So B sub n equals 1 over n. B sub n plus 1 would have to equal 1 over n plus 1, which I have. So this is a true telescoping. If the b sub n plus 1 that I should have when I plug n plus 1 into here doesn't match this, then you do have to expand out the terms to see what cancels. So I can get straight to saying this sum is the limit as n approaches infinity of b sub 1 minus b sub n, the last term. And that's going to be the limit as n approaches infinity of, if you just plug 1 in just to this first thing, here's b sub n. So you get 1 over 1 minus the last term. I guess that should be b sub n plus 1, sorry. Minus the last term, 1 over n plus 1. You're going to get 1. So this series converges. And I know that it converges to 1 by the telescoping series test. If you're ever unsure about whether it's actually telescoping or not, sometimes that gets confusing. It's kind of straightforward in this one. But if these are more complicated and you're not quite sure, you can always expand out terms and just see what cancels and what's left over. You're still going to need to do this limit right here. But yeah, if you just plug in terms, like if you plug in 1, you get 1 minus 1/2. Plug in 2, you get 1/2 minus 1/3. You do this as long as you need to convince yourself that a bunch of stuff is going to cancel. And stop it at like an nth term. So you can see that everything's going to be canceling in here. The 1 will be left over. You'll never get another minus 1 down the line. And if you stop at the nth term, then this will be left over. So that's how you can get straight to there. Take the limit, because remember, the sum of a series is the limit as n approaches infinity of the partial sum. If we say we use a partial sum to estimate this thing, but we're going to use infinite number of terms, well, that is the actual sum. Okay, find the sum. So right now, this either needs to be a geometric series for us to be able to find the sum, or telescoping. This one has to be telescoping because it's not something to the n power, and I see that I can factor the denominator. So I want to split this again using partial fraction decomposition into my two fractions. All right, so if I use the cover-up method, if I let n equal -1, I cover up n plus 1, and I get 1 over -1 minus 1. So that's -1/2. And if I let n equal 1, I cover up the n minus 1. I get 1 over 1 plus 1, so plus 1/2. If you have the same coefficient in front of the summations, go ahead and factor it out. If you don't, if one of these had a 1 and one had a 1/2, then whatever the coefficient is, like whatever the coefficients are that can't be factored out, they need to stay in front as part of the sum here. It just means you would include them in your calculations when you expand terms. We have a 1/2. Put the positive term, make sure you write your bounds every time. Don't just write a sigma. Write the positive term first, subtracting the negative term, so minus 1 over n plus 1. And is this true telescoping? Can I jump right to the limit? I don't think so, because b sub n would have to be the first term. And b sub n plus 1, that means just plug n plus 1 into that. So you would get 1 over n plus 1 minus 1. So it would only be true telescoping where I can skip right to the limit of the first term minus the very last term if I had 1 over n right here. So this just means that more than the first term is going to survive. So we just expand out the terms. All right, so that's going to be starting at 2 here. So 1 over, I need to write this above. So if I plug in 2, get everything all set up. There we go. I'm going to get 1 minus 1/3 plus, plug in 3, 1/2 minus 1/4 plus, plug in 4, 1/3 minus 1/5. I usually stop here with terms. As soon as I see that this is going to cancel with this, I know that I'm not going to get another 1/2 down the line either. So as soon as I see like the first cancellation happening, I know that everything after that's going to cancel. So I know the 1 will still be there. There will never be another 1 that pops up. There will never be another 1/2 that pops up. But the 1/3 is going to cancel. The 1/4 is going to cancel. The 1/5. So I'm just going to say, okay, out to my partial sum, 1 over n minus 1 minus 1 over n plus 1. I'm going to let this keep going, plus dot, 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 because I'm saying that this infinite sum is equal to this. So if I don't have limit notation in here, I can't cut it off. What I can say, though, is that now I know that this sum is equal to the limit as n approaches infinity of 1/2 times whatever's left. So 1 plus 1/2, and then the final term would be like minus 1 over n plus 1. So that is 1/2 times 3/2 minus 0. So this sum of this series is equal to 3/4. So if it's a telescoping series, or I guess I should say this, if you can get it in the form of two rationals being subtracted, then you need to start expanding out terms. And if you can expand things out and things start canceling, then it's going to converge. The question is just, what does it converge to? Okay, determine the convergence or divergence of the series. So you should always be thinking nth term test first, because if the terms are not even approaching 0, it has no chance to converge. So that's this first one. The limit as n approaches infinity of n plus 10 over 10n plus 1 is 1/10, which is not 0. So this series diverges by nth term test. There will never be a converges by nth term test. If you get 0, it just means, oh, this has a chance to converge. I have to use one of the other tests to see. Like this one. The terms are approaching 0. It's bottom heavy. So what are we going to do with this? Well, I see something factored in the denominator, so it's probably telescoping. I'm going to get this set up with partial fractions. And I think I've said this a little bit in this video, but don't be lazy about your notation. Just like when we're doing definite integrals, we have to write the bounds. When we're using summation symbols, we can't just scribble a sigma on here. We have to write from n equals 1 to infinity, or whatever the scenario is. So using cover-up method, if n equals 0, I'm plugging in a 1 over 0 plus 1. I get 1. If n equals negative 1, I'm plugging into 1 over 2n. So I get negative 1/2. So here's one where I can't just factor out. They don't have the same coefficient, so I can't just factor this out. I'm actually going to put the 1/2 in here. So because I do want to write this as one expression in here. So it's 1 over 2n minus 1/2 times n plus 1. You can distribute the 2 through if you want. I'm just going to leave it like that. And I want to expand out terms. Although I could expand out terms, but now that I'm looking at this, it's like, well, b sub n is 1 over 2n. b sub n plus 1 is 1 over 2n plus 1. So I actually do have telescoping. So if I don't expand out terms, I could just say this is going to be the limit as n approaches infinity of the first term minus the n plus 1 term. What would that be? That would be 1 over 2 times 1 minus 1 over 2 times n plus 1. So that would be 1/2. That's the sum of the series. On my PDF answer key, I believe I expanded out the terms, which you could do as well, and see what's canceling out. Let me check if I did that, actually. Let's see. Yeah, so I did expand here, and you can see, yep, everything except the first and the last term canceled out. All right, last couple. So here's a geometric. I want to read the directions again. What was it? Converge or diverge. So this is geometric. I can see that r is 1/2. So it doesn't say what does it converge to. I am going to find that sum. A sub 0 would be 4. If you want to rewrite this as 4 times 1/2 to the n, you can. But we do know that this converges to 4 over 1 minus 1/2. That's 4 over 1/2 converges to 8. So, oops, I didn't answer this previous one. Sorry. So the previous one series converges by telescoping series test. And this one, this series converges by geometric series test. And both of these, we know what they converge to. This one converges to 8. Previous one converges to 1/2. All right, last question in this assignment. ln, we haven't seen ln before, right? So this is not geometric and it's not partial fraction. But remember, nth term test. Always check that first if you're not sure what to do. Start there. So what is this limit of the term? Are the terms approaching 0 or not? So when you plug infinity into this, you get ln of 0, which does not exist. But also think about the natural log graph. There is a vertical asymptote at 0. So as you're approaching 0, you're getting like negative infinity is what I would say for that. So that diverges. The terms are diverging. Diverges by nth term test. So we don't have to bother with any of our other tests. We wouldn't be able to do anything else anyway. We can't. This is not telescoping and it's not geometric. So we don't have any other tools right now to deal with that. All right, that finishes this homework assignment. Remember, we're doubling up this year and because of snow days and doing homework 14 as well.